Hi, I'm Alan Downey, and this is a tutorial on exploratory data analysis with pandas and matplotlib. So we're going to do exploratory data analysis and some of the Python tools that go along with it, and a little bit of computational social science. And I'll explain that in a minute. We're going to use Jupyter notebooks that are running on Colab, so you don't need to install anything. I'm going to introduce each notebook, and then you can work through the notebook at your own pace, and then come back and we'll debrief on what was in the notebook. If you load these slides, you'll find all the links to the notebooks and also additional material. And that URL is tinyurl.com/EDAPy20. So here's the outline. I'm going to introduce the material a little bit, and then Notebook 1 is mostly about data cleaning and validation, which I promise is more interesting than it sounds. Notebook 2 is about distributions, cross-tabulation, and local regression. And then Notebook 3 is group by, pivot tables, and visualization. We'll be working with data from the General Social Survey, and it includes material about political alignment and political ideology. What I mean by political ideology is the things that you think about these topics: economics, education, healthcare, labor, criminal law, and so on. Your answers, your attitudes about all of those things make up your political ideology, which includes both how you think society should work and what the methods are that you think can achieve an ideal arrangement. And that's how the Wikipedia page describes that. One way to think about this is your political ideology is a high-dimensional space. So I could ask you 100 different questions and then plot your answers as a point in a 100-dimensional space. And if you think if there were 100 questions and they were all yes/no questions, that means that there would be 2 to the 100th power locations in this high-dimensional space. And that's more atoms than there are in the universe. So it is almost certain that you have an ideology all to yourself. You are a unique snowflake in the best sense of that word. But we usually don't think of it as a 100-dimensional space. Culturally, we have a lot of ways of reducing dimensions. So dimension reduction is reducing the number of random variables to get a set of the things that we think are the principal variables. In the context of political ideology, there are lots of different ways to plot ideologies in different spaces. This is the one-dimensional space that is maybe the most common, certainly in the US and maybe in the world, organized from left to right, where left is liberal or progressive and right is conservative or more traditional. That's just a one-dimensional space. There are other versions of this. This is a Nolan chart that's an attempt to map the high-dimensional space into just 2 dimensions. Here's a version that seems to be sort of 3-dimensional, although it's not clear that each axis has 2 symmetric endpoints. And here's a version that I'm really not sure how to interpret. I just found a lot of diagrams that pertain to political ideology. And these are all the ways that people have tried to organize our thinking about this, but it's always lossy. You lose information when you reduce dimensions, and none of these is uniquely correct. And none of them are politically neutral. They all have some value judgments embedded in them. So in the US, we typically think in terms of one dimension from left to right, and we think about red state, blue state, or liberal conservative, or Democrat, Republican. I guess one of those is reversed, but you get the idea. For this tutorial, we're going to focus in on what I'll call a political alignment, which is on an axis from liberal to conservative, as distinct from political affiliation, meaning affiliation with a particular political party, And those things, often go together, but don't always go together. And one of the things we'll do is look a little bit at what these axes mean by looking at relationships between what people say, what their political alignment is, what party they belong to, and specifically what attitudes and beliefs and preferences go along with those self-described affiliations. So to get started, I'm going to give an example. I picked one of the variables from the General Social Survey and ran the analysis that we're going to learn to do in this tutorial. So you'll see the results up front, and then you'll see the details of how to do it. Again, this is from the General Social Survey, which is collected by a research group at the University of Chicago. They've been running this survey since 1972, and there's a suite of questions that they've asked almost every year with a different group of respondents each year. One of them is about homosexuality, and I'll read you the text of the question. They asked the respondents, what about sexual relations between two adults of the same sex? Do you think it is always wrong, almost always wrong only sometimes, or not wrong at all? Now, if those responses, the choices that the respondents were given, might seem a little odd now, but the question was written in 1973, and they try not to change the text because every time you change the text, you elicit somewhat different responses. And in fact, in 1973, a large majority responded always wrong. So looking down the first column of this table, the responses in 1973, about 1,053 people said always wrong, and the other responses were in the hundreds to 200s. Now that has changed, as you are probably aware, and this graph plots those changes. So for each year when the question was asked, I computed the fraction of respondents who said yes who gave the response that same-sex sexual relations are always wrong. The circles here plot the actual proportions from year to year, and the line is a smooth local regression curve through the data. And you can see that at the beginning of the survey in 1973, it was about 75% who thought that homosexuality is always wrong. And then starting a little bit before 1990, it started to decline and has been declining quite steeply ever since. So it's now, I think, down at about 30%. If you're curious about what caused that, we have some history on this, and there's a link there that will take you to at least a starting place. One of the other questions is about self-described political alignment. Do you think of yourself as liberal or conservative? And the responses are on a scale from 1 to 7, where 1 is extremely liberal, 4 is moderate, and 7 is extremely conservative. I'm going to put people into just 3 groups by liberal, moderate, or conservative. And it turns out that the proportion of people in each group is about the same. It's almost a third, a third, a third. So now I'm going to group those respondents, the same as the previous graph, but I'm going to group by political alignment and then plot by year. And what we can see is that the blue line at the bottom is for people who describe themselves as liberal, and they are the least likely to think that homosexuality is wrong. A little bit of a double negative there. They have the most positive attitude toward homosexuality. Not surprisingly, conservatives have a less positive attitude. More of them think that it's wrong. Although all 3 groups, including moderates, have been declining over the same period and declining at almost the same rate. So the slope of these lines is almost the same. They're just offset from each other. Interestingly, the last point for conservatives is at about 55%, which is very close to the first point for liberals. I wrote a blog article about this, and if you're interested in a little bit more detail and my comments on it, you're welcome to follow that link. The observation that I made there is that you might be surprised at how liberal conservatives are now. The fraction who think homosexuality is wrong is down to 60%, which is to say that conservatives now are as liberals were in 1973. At the same time, the fraction of people who describe themselves as liberal and conservative has been mostly unchanged. A little bit of variation from year to year, but mostly unchanged. What has really changed in the last 50 years is what those identities mean. That is, the set of attitudes that come with those identities. Now, I just looked at that one variable, and part of what you'll get to do during this tutorial is look at some of the others. There are about 150 other variables in this data set that ask questions similar to this one, and we'll get to see what some of those patterns are. Because there are different stories that we tell about what's going on with these kind of changes. You'll sometimes hear people say that conservatives are winning, that liberals are winning, that the pendulum just swings back and forth and nothing ever changes. We're just locked in a perpetual tug of war. With these data, I think we can shed some light on these stories and get a sense of which ones are true or not true for different variables and different attitudes. So we'll find out. I'm going to introduce the first notebook. There's a link there that will take you to the notebook. And what it's about is reading data and validating. We're going to talk about resampling, which is a statistical idea that you may or may not have seen before. And then taking the data after we've cleaned it and storing it in an HDF file. So if you click on that link, it'll take you to the first notebook. And this is a Jupyter notebook that's running on Colab. If you haven't used notebooks before, the most important thing to know about is the Shift-Enter command, which will execute the current cell and move on to the next cell. So the first few cells here are text, and you can read through that. As you work through the notebook, you can read the text. When you get to the first cell that has code in it, when you run that cell, you'll get a warning from Colab that tells you that this notebook was not written by Google. It was written by me, and so you can go ahead and run it. It doesn't do anything malicious, and in fact, it would not be easy to do malicious things in a notebook. Well, I don't know. Anyway, this one doesn't do anything malicious. So I load up some of the libraries that we're using, including the ones I mentioned, pandas and matplotlib. The next section reads the data. So it downloads the data first, and then has some code here that I wrote that reads the data and then eventually puts it into a pandas data frame. This I wanted to show you in part because this is the least important part of what we're going to do. And if the details here are unfamiliar, you can mostly ignore them. The one useful thing is the function that's running right now, which is a pandas function that's called readFWF, which stands for read fixed width font, fixed width format, and that's the format that the data are in. Part of the reason I had to do this, the GSS publishes the data in a variety of formats, and pandas can read a variety of formats. So often when you're trying to import data, the goal is to get those two things to go together. In this case, there's not a clean combination that works very well. So I ended up writing code that would read a Stata dictionary file that contains the metadata that tells me what format the data file is in. And then I used, as I mentioned, read fixed width format to actually read the data. The result then is a pandas data frame, and the notebook is going to walk you through the next few steps. When we come back in the next video, we'll debrief on the first notebook, and I'll introduce the second notebook.